Yeah, we're going to be looking at electronics components, and the electronics component we'll be looking at today is resistor. In the course of this class, we're going to learn about resistors. We're going to know about the resistor color coding. We're going to identify resistor symbol and how to calculate the value of resistors with resistor color coding. So, what's a resistor? A resistor is an electrical component that does not allow the free flow of electric current, right? So any electronic component that does not allow the free flow of electric current is a resistor. And the capacity of a resistor to oppose the free flow of electric current is what is known as resistance. And the unit of measurement is in ohms. All right, so get that straight. So resistors can either be fixed or variable, right? So fixed resistors are resistors whose resistance cannot be changed. In other words, the specified resistance that the manufacturer gives is what the actual resistance is. It cannot be changed. While variable resistors are resistors whose resistance can be changed. So fixed resistors. Now, fixed resistors, this type of resistors are either color-coded or number-coded. Please take note. They are either color-coded or number-coded. Now, as this will continue, you're going to see the difference between a color-coded resistor and a number-coded resistor. The color-coded resistors are mainly through-hole mounted, that is THT, through-hole technology. They often have leads through which you can put them through your circuit board, your Vero board, and solder them to the circuit board. Now, the number-coded resistors are mostly surface mounted, right? And you make use of the SMD, the surface mounted device technology, in order to be able to solder them to your Vero board. Now, take note, resistors are not polarized. They're not polarized in the sense that you do not really pay attention to the direction you fix them on the circuit. You can connect them any direction and they're going to work. The resistors don't have positive, they don't actually have negative. All right, this is an example of a color-coded resistor. I'm sure you must have seen this before several times. So in the course of this teaching, I'm going to teach you how to identify, how to use these colors to identify the resistance of a resistor. All right, this is an example of a number-coded resistor, another example of a number-coded resistor. This is the electronic symbol of a fixed resistor. Wherever you see the symbol, it represents a fixed resistor. All right, so color-coded resistors and number-coded resistors. Let's proceed. So resistor color coding. Now, the color-coded resistors are actually made up of different color bands. And the color bands actually ranges from about 3 to 6 bands. All right. These are the very common ones. But for the sake of our teaching, we're going to concentrate on 4 color band and 5 color band resistors because these are the type of resistors we're going to be making use of regularly. And they are very common in the market. All right, so how do you interpret the colors? All right, how do you interpret the resistor colors? Now, when you have a 4 color band resistor here, you're definitely going to see 4 color bands on it like this. This first color band represents the first digit, and the second one here represents the second digit. The second color band represents the second digit, and the third color band represents the multiplier, and the fourth color band represents the percentage tolerance. Okay, this is for a 4 color band resistor. For 5 color band resistor, I will show you how to identify the colors. So for us to be able to accurately interpret the resistor color coding, we're going to make use of this resistor color coding table. All right, so we're going to make use of this color coding table. For example, if the first color here in the first band is red, for example, if it is red, then you come to this table where you have first digit you have red, you check first digit red, you check the number on red. Okay, so the number on red here is 2, and 2 becomes the first digit of that resistor. Now, if you check the second digit, if it's green, you check it under second digit. What is the value of green? Under second digit is 5. Okay, so this becomes our second digit. Now, you go to the third digit, you have the third color band, sorry, you have your multiplier. Okay, now your multiplier here, in this case, is red. So this time you don't check because it's a 4 color band resistor. You don't check under third digit, you go to multiplier, and the color we have here is red. And the figure you have on red is 100. Okay, so you're going to multiply the first digit. First digit is 2 by second digit 5. Okay, so we have 2, 5, 25 times 100. This is the multiplier, and that's going to give you the value of the resistor. Let's take further examples. Let's take this as a case study. This resistor here, we have brown as the first color. Now, you may want to ask me, how do I identify the first color? How do I know the direction to actually start counting from? Okay, how do I know the direction to actually start counting my first color band from? Because if you actually pick a resistor, in reality, you see that there's no indication to tell you that you start counting from here to this other side. All right, so now take note of the resistor. There is a side which the colors are closely packed together. There's always a side in the resistor that the colors are closely packed together like this. All right, the side which the colors are closely packed together, the color band are closely packed together, you start counting from that end towards the side where they are loosely packed together. Okay, so this, we are using this as a case study, as our example. We have brown here. Okay, so brown here, color brown, under first digit we have 1, right? So under brown first digit we have 1, so our first digit becomes 1. Then second color band which represents our second digit is black. You go to black, under second digit we have 0, which is what you have here as 0. Okay, so we have the third color band. Remember, we are dealing with, this is an example of a 4 color band resistor. So we are at the third color band, which is our multiplier, and we have red. So we come to multiply, we check the value of red is 100. So then we have our fourth color band, which is our percentage tolerance, which is something we're going to talk about later in this class. So we have our percentage tolerance, and if you check here, we actually have gold. All right, so under percentage tolerance we have gold as 5%. So our percentage tolerance here is 5%. So our resistor value now is this. Remember, our first digit is 1, which is this 1. This is 1. Second digit is 0. Second digit is 0. Remember, 0. Multiplied by 100, our multiplier, 100. And this is going to give you 1000 ohms, which is approximately 1 kilo ohms. All right. So this is that for a 4 color band resistor. Now, for a 5 color band resistor, we have our first digit here as 0. Look at this, as yellow, sorry. Now, yellow first digit, you go to first digit, you have yellow with the digit of 4. Second digit here, you have purple with digit of 7. So we have 4, 7. Now, for a fifth color band resistor, the third color band represents the third digit. Get it? So the third color band represents the third digit, unlike the four color band resistor where the third color band is the multiplier. Okay, so the third digit here is 0. So we have 4, 7, and 0. Then the fourth color band represent our multiplier. So we have 4, 7, okay, 0 multiplied by 100. That will give us the value of this 5 color band resistor. Let's proceed. Now let's look at number coding. All right, resistor number coding. Here, you must have seen this type of resistors in circuit boards, mobile phones, your MP3 players, and the rest. Now, when you see 4 arrow 7, it actually means the resistance. Okay, so how do we interpret it? The first digit here is your first digit, which is first digit is 4. That becomes 4. All right. Now, take note, each time you see a letter, when you see a letter, an alphabet, okay, in between two numbers, like arrow, 4, arrow 7, this alphabet here represent a decimal point, okay? So we have 4 point, all right? Then the third digit is 7. So the value of this resistor is 4.7 ohms. 4.7 ohms. You get it? All right, so let's look at this. So we have this as our first digit is 1, all right? Second digit is 0, all right? Now, we don't have any letter here. The fourth digit becomes our multiplier. And the last digit, which is this third digit, represent the number of zeros or exponential, all right? So here we have 4, which is 4 zeros, 1, 2, 3, 4, all right? So we have 1 and 0, 1 and 0, first and second digit, multiplied by, okay, multiplied by 4 zeros, which at the end of the day is going to give us 100 kilo ohms. Okay, it's going to give us 100 kilo ohms. So let's look at variable resistors. Variable resistors are resistors whose resistance can actually be changed by either applying a mechanical effort or by some other environmental quantities such as light or heat. Now, variable resistors, we can have them as potentiometers. We can have them as rheostats. We can have them as photoresistors or light-dependent resistor, and as well thermistors. Now, it becomes a potentiometer when it is used to change the value of voltage. All right. When you are using it to change the value of voltage, it becomes potentiometer. All right. Potentiometer is used to vary voltage in an electric circuit, and it has 3 terminals. This is a very good example. This one terminal, another terminal, and this is the third terminal. So we have 1, 2, 3. All right. So, and then as a rheostat, it is used to change the value of current in a circuit. As a rheostat, it is used to change the value of current in a circuit. Now you can use this variable resistor, but then you are going to make use of just only 2 terminals instead of the 3 terminals. Remember, when using it as a potentiometer, you make use of the 3 terminals. When making use of it as a rheostat, you make use of only two terminals. So this is a very good example of how variable resistors are connected. As a potentiometer, you connect A and C, all right? So you connect A and C together, then this will become our A, and this becomes our C, right? You connect A and C, and the middle terminal here, which is B, becomes our output. So you make use of the three terminals, all right? You're going to make use of the three terminals here. Then for a rheostat, you make use of only two, all right? You make use of only two terminals. You don't connect the third one. So you make use of A and B. I'm laying this foundation because we're going to be doing a lot of practicals in subsequent videos. So please, you have to get yourself used to this so that you will understand by the time we'll be doing practicals, you'll be carried along. All right. Okay. So let's look at light dependent resistors. Light dependent resistors. A light dependent resistor is actually a resistor whose resistance depend on light, all right, light intensity. Light dependent resistor is a resistor whose resistance changes in accordance to the light intensity, and this is the symbol. This is how it looks like. Physically, this is how it looks like, all right? When light falls on the surface, the light intensity, when it falls on the surface, the higher the light intensity, the lower the resistance. So light causes it to reduce its resistance. Okay. So the higher the light intensity, the lower the resistance, and the lower the light intensity, the higher the resistance. Okay, so take note of that. So variable resistors, we're looking at thermistors. Now, a thermistor is a type of resistor whose resistance depend on temperature. All right. So unlike the LDR, the resistance depend on lightning, the intensity of light. While that of thermistor, the resistance depends upon temperature. Okay, so get that. And this is the symbol of a thermistor. This is how it looks like. All right. These are thermistors, this various type of thermistors. These are they look like physically, all right? So the lower the temperature, the higher the resistance. Take note. The lower the temperature, the higher the resistance. The lower the temperature, the higher the resistance. The higher the temperature, the lower the resistance. All right, so get this. We'll be doing some practical videos next time. So with this, you understand resistors, go back to the video, watch it again, and take note of how to identify resistors using color coding or number coding. All right, and then come to watch through the video again. Please, if you like our class, do well to comment and share with your friends. If there's something you need us to add to this, you do well to let us know. Right? Thank you.